Hello, my dear friends. Our presentation is entitled Gamified Human-Centered Model for Behavioral Management Under Water Stress in the Context of Industry 5.0. The paper is co-authored by Teodor Daskalov and Nevyana from the Faculty of Economics and Business Administration at Sofia University, St. Clement Ohridski. The central question of our work is how household water consumption can be addressed not only through infrastructure, pricing, or monitoring, but also through a human-centered behavioral feedback system. We proposed a conceptual model that combines social comparison, gamified feedback, loss framing, habit persistence, and contextual disturbance within a closed-loop system. The model is illustrated through a simulation of 100 synthetic households. I will briefly present the conceptual framework and formal model, the simulation results, and the implications for Industry 5.0. Urban water stress is intensifying as a result of population growth, climate variability, and increasing pressure of municipal infrastructure. In this paper, we approach the problem from the demand side. Household water consumption is treated as an adjunctable behavioral component as overall urban water pressure. This perspective becomes particularly relevant with the development of smart metering. Smart meters make it possible to move beyond aggregate billing and provide individualized information about consumption. However, our interest is not simply in monitoring water use. The important question is whether consumption data can be transformed into timely and meaningful feedback that can influence subsequent behavior. This also fits the logic of Industry 5.0, where people are not treated as passive end users, but as an active participants in socio-technical systems. Everyday household decisions affect aggregate demand. Therefore, behavior regulation can become an integral component of sustainable resource governance. The research gap addressed by the paper is relatively straightforward. Existing approaches usually examine smart metering, nudging, or gamification separately. We proposed a more compact formal structure in which household behavior is represented as an adaptive state within a feedback loop. The model links social comparison, rewards alliance, and loss framing in one update structure. At the same time, it distinguishes direct corrective effect from the intensity of gamified feedback. Importantly, we also keep rebound and contextual disturbance inside the same behavioral model. This means that a temporary increase in consumption is not automatically treated as a failure or of the intervention. It becomes part of the dynamics that the system has to respond to. Our contribution is therefore not empirically validated intervention system. It is a human-in-the-loop socio-technical behavioral system model, combining ideas from cybernetic feedback regulation, behavioral economics, and human-centered adaptive system design. Now I will move to the formal conceptual model. The central idea is to represent household water consumption as a behavioral state that changes over time. The model combines 5 elements: social comparison, gamified alliance, loss framing, habit persistence, and contextual disturbance. Household consumption is evaluated not only against the household's own baseline, but also against the current social norm. The model then translates these deviations into different types of corrective feedback. At the same time, habit persistence and external disturbances allow consumption to temporarily increase again. This is important because the model does not assume that behavioral change is linear or permanent. Instead, it represents household behavior as a part of a continuous human-in-the-loop adaptive regulation process. The proposed system operates as a five-stage adaptive loop. First, household water consumption is monitored. Second, consumption is normalized against a reference baseline. Third, household performance is compared with the current social norm. Fourth, this information is translated into intervention signals combining peer comparison, reward-oriented feedback, and loss framing. Finally, subsequent consumption becomes the input for the next cycle. The important point here is that the households remain decision makers. The system does not directly control their behavior. Instead, it structures the informational environment in order to make more sustainable choices more resilient. This is how the model applies the human-centered perspective of Industry 5.0 to the demand side of the water management. To examine the internal behavior of the proposed model, we conducted a simulation with 100 synthetic households over 12 periods. Baseline consumption was generated around the initial mean, rankings were recalculated in every period, and an external disturbance term was introduced to represent contextual variation. The simulation uses illustrative coefficients for the different behavioral mechanisms. For example, beta controls the salience of the gamified signal, gamma represents the loss-framed response to exceeding the household's baseline, and delta represents relaxation toward habitual consumption after previous savings. It is important to emphasize that these parameters were not estimated from real-world data. Therefore, the simulation is not intended to predict an actual percentage reduction in household consumption. It proposes to examine whether the proposed update structure produces the behavioral dynamics expected from the conceptual model. The baseline simulation shows a decrease in mean consumption from 9.91 cubic meters to 6.21 cubic meters, corresponding to an illustrative reduction of approximately 37.3%. However, the percentage itself is not the main result. The number should not be interpreted as an expected empirical effect because the simulation uses synthetic households and illustrative parameters. What's more important is the behavioral pattern generated by the model. Consumption declines, but a rebound episode can occur. When households exceed their own baseline, the loss-framed mechanism becomes active. At the same time, social comparison continues to apply corrective pressure to households above the current group norm. Gamified feedback maintains the salience of these signals. Therefore, the model produces a regulated but not linear trajectory, decline, temporary rebound, and renewed correction. The main contribution of the model is its integrative character. Rather than treating smart metering, gamification, social comparison, and behavior correction as separate tools, the model places them with a single adaptive structure. This is particularly relevant to the Industry 5.0 perspective. The household is not treated as a passive target of optimization. It remains an active and informed participant in the socio-technical system. The system provides feedback, but the decision remains with the household. In this sense, the model represents a shift from automation-centric optimization toward collaborative and human-centered social-technical regulation. It is also recognized that behavioral change is rarely linear. Temporary setbacks can occur without meaning that the intervention itself has failed. There are several important limitations. First, the study remains conceptual. The simulation uses synthetic data and illustrative parameters rather than empirical estimates. Second, there has been no field implementation to test the magnitude, robustness, and boundary conditions of the proposed effects. Future research should therefore calibrate the parameters using real consumption data and connect contextual disturbances to observable factors such as weather, household occupancy, and episodic demand. Another important issue is fairness. Households differ in size, occupancy, appliances, irrigation requirements, and seasonal exposure. Therefore, peer groups should not be created simply on the basis of raw consumption. Finally, a human-centered implementation requires transparency and proportionality. Gamification should support self-regulation rather than become coercive. This means explaining how data are used, retaining only the data that are necessary, and avoiding public shaming or excessive ranking pressure. To conclude, this paper proposes a demand-side behavior regulation model for household water stress management in the context of Industry 5.0. The model integrates social comparison, gamified salience, loss framing, rebound, and contextual disturbance within one closed adapted feedback loop. The simulation demonstrates that this structure can generate aggregate consumption reduction while still allowing temporary rebound and subsequent correction. At the same time, the study should be understood as a theoretical and simulation-oriented architecture rather than as a validated operational control system. The next step is therefore empirical calibration using real household consumption data, followed by testing under realistic conditions. The broader objective is to develop water management systems in which technology supports behavioral adaptation while preserving human autonomy, transparency, and fairness. My dear friends, thank you very much for your attention, and now it is time for questions and answers. Have a very nice day.